Caddis Maximus here, this time with a review of the GearWrench 1/4 inch drive, flex head, long handle, 120 teeth, 120 XP, 3-degree 1/4 inch drive ratchet. Let's go and take a close look at this while we talk about it. So these are current. I've seen these in all over online, Amazon, everywhere. I've been, I had some comments and some people have been reporting about some other GearWrench tools that have really fallen off in quality. This doesn't appear to be one of them. There's a part number. It is a plastic insert handle, or excuse me, the handle is pressed onto the steel shank. The shank indeed goes all the way up to right about here, right where the little indentation at the end is. So it is nice. It's metal all the way through. Has a pretty good finish. What GearWrench does here is they use, I believe, offset pawls. We'll take a look inside there. They also make their ratchets a bit thinner. For instance, here's a proto. You can see it's a bit thicker. So I'm a little curious about it. They do use a screw, so you can retension and adjust that. Because it's a thinner beam, they make these lugs pretty thick. I am impressed because the rounding is pretty even, which is the first telltale sign of any of these kind of flex heads, is how round that is and how well centered the hole is drilled. It has a really strong ball dentant, which I appreciate. And of course a standard reversing switch with a 3 degrees stamped on it. One thing that does kind of concern me is for how small the teeth are, you can see that they've machined out the inside and then had to set in the plate and have enough space for a snap ring. And if you look, it goes pretty deep. That whole pocket, that's how deep it is. And then there's a plate. And there just isn't a lot of space. It appears about less than half the space of the ratchet's actually available for the wheel and pawls. And so that's been a little bit concerning. Let's zoom out here. And let's go and get that snap ring out and actually see what it looks like inside. Alright, hopefully I don't poke my eyes out here or have the snap ring pull off. It does have some pretty big eyes in the snap ring. There we go. Let's leave that on there. We'll go ahead and pull this out. So, one thing that we can see is this bottom plate here is wafer thin. Surprisingly thin. I guess they feel it's so deeply offset that they don't have to worry about it. But in the situation that something comes, you do drop it and it hits the end of a bolt in a toolbox and something bangs, that metal is so thin it could dent. And when that happens, it'll interfere with the ratcheting action. They do attempt to make it sealed. If you look inside that head, there's a little O-ring in there. Maybe not the best O-ring, but it is undercut, and they did put an O-ring in there to attempt to keep crud out. That's a nice touch. And it is solid on the back. Pretty darn fine teeth on that. Now let's take a look inside the ratchet itself. And it is indeed twin pawl. Where's a nice bright flashlight here? Just a second. Here we go. You can see that there's the twin pawls. It is a twin pawl design. So one pawl is slightly offset from the other. The top pawl doesn't have any gaps, but you can see that the bottom pawl does. And that's to help with the offset. I believe when you put a lot of torque on this, one of the pawls will shift, and then it will rely on the stack of both of them. As you can see, it is one large pawl, or one single pawl that actually shifts back and forth when you reverse. And this ratchet's been okay. It hasn't had a problem with self-reversing, and there's quite a few teeth, about 10 teeth engaging. The issue is just how small those pawls are. In just a second, let me get them out of there. Inside the ratchet we have, let me put the pawls down, which is a nice touch. There's actually two indentations, two little spring-loaded pins in there, one for each pawl, so that's a nice touch. And it looks like that's how it's captured. If you press those or take those out, then you'll be able to pull out the lever. So that's an interesting way of keeping the lever in. Here's the two little pawls. As you can see in my finger, they are tiny. And so I would worry about overloading these, to tell you the truth. They're just so small that I wouldn't place any bets on how much torque this ratchet would actually take because of that. But it is nice because it is such a fine tooth, and it isn't a clutch type, which you have to be real careful, because clutch type ratchets, even though they have infinite spacing, are easily damaged from over torquing. So these kind of ratchets are about the next best thing. Just remember that you're sacrificing a lot of surface area. Even though I'll admit that these pawls are pretty wide, they're still just super tiny. And for how deeply inset, they could have done a slightly different design, had a standard cover plate. That would have given them more space inside the ratchet to have both taller pawls and a larger wheel. Anyway, I really appreciate you guys watching. Generally speaking, I would recommend this ratchet if it's on sale, but I think for its retail price or MSRP, it's still not too bad. But I wouldn't try doing a lot of torque tests. I'm pretty sure under testing that the ratchet would fail before the square failed. And really, when it comes to ratchets, a good quality ratchet pretty much always can be guaranteed that the square is what's going to end up failing. So, once again, thanks for watching. Please subscribe. Caddis Maxing us out.